All right, today we're going to talk about radical equations and how to solve equations that have radicals on both sides. All right, so here are the steps to solving radical equations. You isolate the whole radical. So the radical contains the variable. So just think about isolating the variable. So you're going to remove everything to the other side and get it away from the variable. Step 2, once you have the radical that has the variable in it, once that is isolated and all by itself, you're going to square both sides to remove the radical. And then sometimes you have to finish solving for x, because inside the radical, you might not just have x, but you might have an equation inside the radical. And then the last step is check your answers, because sometimes you can get extraneous answers. So let's look at a problem. We have 3 square root of x equals 24. So the first step is to isolate this square root, this radical. So we have to get rid of this times 3. So to undo the times 3, we'll divide both sides by 3. And we divide by 3, that leaves us just the square root of x. And then we divide by 3 on the other side, 24 divided by 3, we get 8. And now that our radical is isolated, we can square both sides. So we square the left-hand side and the radical symbol disappears, leaving us just x. And then 8 squared becomes 64. So we get our answer, x equals 64. All right, let's try this one. The square root of x minus 7 equals 9. So again, the first step is to isolate the radical. So we have to get rid of this minus 7. To undo minus 7, we plus 7. So if we plus 7 on both sides, on the left-hand side, we're left with the square root of x. And then on the right-hand side, we're left with 9, because 2 plus 7 is 9. And now we'll square both sides, eliminating the radical on the left-hand side, leaving us just x, and then 9 squared is 81. All right, let's try this one. The square root of x plus 5 equals 3. So step 1, get rid of this plus 5 by subtracting 5. So that leaves us the square root of x equals negative 2, because 3 minus 5 is negative 2. So we square both sides, right? So that means x is equal to 4, because negative 2 squared is 4. Okay, so let us check the answer. If x is equal to 4, so the square root of 4 plus 5 equals 3. Well, the square root of 4 is 2, and then 2 plus 5 is 7. That's not 3. So that means that this answer is not a solution, and it's extraneous. It's an extraneous solution. And here is a hint. Anytime that you solve for your radical and it's equal to a negative number, anytime you have it equal to a negative number, you will get no solution or extraneous solution. All right, let's go ahead and practice. Go ahead and try this one and see what you get. All right, you should have gotten 25, because the first thing you would do is divide by 4. So you would get the square root of x equals 5, and then you square both sides, and 5 squared is 25, which is choice number 3. Let's try this one. So we've got 5 square root of x plus 6 equals 21. So the first thing we want to do is isolate the radical. So there's 2 things we have to take care of. We have to take care of this times 5 and this plus 6. So the question is, which one do we get rid of first? Well, back in pre-algebra, we learned that when you're solving a 2-step equation, you deal with the addition and subtraction first. So we want to get rid of this plus 6 first. So we're going to subtract 6 from both sides. So now we've got 5 square roots of x equals 15, because 21 minus 6 is 15. Then we'll divide both sides by 5, leaving us the square root of x equals 3. Now the very last step is to square both sides, and we get x equals 9. Let's try this one. For this problem, before we can isolate the radical, we have to combine like terms. So we've got 2 square roots of x's plus 5 square roots of x's. So think of it 2 apples plus 5 apples. How many apples do we have? We have 7. So we can combine like terms and we get 7 square roots of x plus 10 equals 38. Now we've got a two-step equation. So the first thing we want to do is subtract 10 from both sides. So now we've got 7 square roots of x equals 28. The next step will be to get rid of that times 7 by dividing both sides by 7. And when we divide both sides by 7, we get the square root of x equals 4 because 28 divided by 7 is 4. Now our last step is to square both sides, which eliminates the radical symbol, leaving us just x, and then 4 squared is 16. All right, so for this problem, this is a little more intense, but we're going to start out the same way. We're going to get rid of this plus 6, okay? So we're going to subtract 6 from both sides, leaving us a square root of x plus 3 equals 6. Now, you might want to try to get rid of this plus 3, but the reality is you can't yet because it is inside the radical symbol. It is protected under that radical symbol until you eliminate the radical symbol. So for right now, just leave it be. So now we've got the square root of x plus 3 equals 6. And since there is nothing on the outside of the radical symbol now, the radical symbol is isolated. And so since it's isolated, we can square both sides. And when we square this on the left-hand side, the radical symbol is going to be eliminating, leaving us just x plus 3. And then 6 squared is 36. So now we solve for x by subtracting 3 from both sides, and we get x is equal to 33. Okay, go ahead and try this one to see what you get. All right, you should have gotten option number 3, which is 98. The first thing you should have done is added 7 to both sides. So you would have gotten the square root of y plus 2 equals 10. And then the next step would be to square both sides. So you would get y plus 2 equals 100. So then to solve for y, you would subtract 2, and 100 minus 2 is 98, which is option 3. Okay, so go ahead and try this one to see what you get. Okay, the answer is 94. So the first thing you would want to do is get rid of this 4, right? So you subtract 4 from both sides. So you get negative 2 square roots of x plus 6 equals negative 20. And the next step, you would divide both sides by negative 2. And when you divide by negative 2, the negatives cancel out, leaving you the square root of x plus 6 equals 10, positive 10. So then you square both sides, and you get x plus 6 equals 100. And then you subtract 6, leaving you 94. Okay, so let's look at this problem here. We've got 4 square root of 8y minus 5 plus 2 square root of 8y minus 5 equals 18. So the first thing we have to do is combine like terms. And these are like terms because the radicals are the same thing. So 4 apples plus 2 apples equals 6 apples. So we get 6 square root of 8y minus 5 equals 18. So the next step will be to divide by 6. So we get the square root of 8y minus 5 equals 3 because 18 divided by 6 is 3. Then we square both sides. So 8y minus 5, that's what's underneath the radical, equals 9 because 3 squared is 9. So now we solve for y. We add 5 to both sides. So we get 8y equals 14. And so then we divide both sides by 8. So we got y equals 14 over 8, and we reduce that fraction, and we get 7 over 4 as our final answer. All right, so let's look at this one. So for this one, we have to get our radicals on the same side. So what I'm going to do is I'm going to subtract the square root of 3x plus 7 from both sides. So when I subtract that from the left-hand side, it's eliminated. It's no longer there. And when I do it on the right-hand side, I've got 2 square roots of 3x plus 7 minus 1 square root of 3x plus 7. So 2 apples minus 1 apple leaves me just 1 apple. So now I'm left with negative 15 equals the square root of 3x plus 7 plus 6. And now I'm going to subtract 6 from both sides, and I get negative 21 equals the square root of 3x plus 7. Well, remember, now I have my radical isolated, and my radical is set equal to a negative number, which means that there's no solution, or the solution that I would get would be extraneous. Okay, go ahead and try this one and see what you can get. Okay, you should have gotten the answer negative 1. The first thing you would do is subtract 18. And when you subtract 18, you would have gotten 2 square root of y plus 4, y plus 5 equals 4. And then you would divide by 2, so you would get the square root of y plus 5 equals 2. And then you square both sides, so you get y plus 5 equals 4. And then you subtract 5, and then 4 minus 5 is negative 1, which is option number 1. Okay, go ahead and try this one here. So remember, you want to get your radicals on the same side. My hint would be subtract the square root of 3y plus 4 from both sides. All right, you should have gotten the answer 5/3, because if you would have subtracted the square root of 3y plus 4 from both sides, you would have been left with 7 equals 7 square roots of 3y plus 4 minus 14. And then you would have added 14 to both sides, and when you did that, 7 plus 14 is 21. And then 21 divided by 7 is 3, and then 3 squared is 9, and then 9 minus 4 is 5, and then 5 divided by 3 is just 5 over 3, which is option number 3. All right, let's talk about exponential equations now. So exponential equations have a variable in the exponent, okay? So not the base, but the actual exponent has a variable in it. So an example would be 8 is equal to 2 to the x power. So we know that 8 can be rewritten as 2 to the third power, because 2 times 2 times 2 is 8. And the trick is that if 2 to the third is equal to 2 to the x, then that means x is equal to 3. So this works with any exponential equations. If your bases are the same, so again, if this base and this base is the same, then the exponents are equal. Whatever your first exponent is equal to your second exponent. And this is really useful. You can solve all kind of complicated exponential equations using this property. So again, if the bases are equal, the exponents are equal. Let's look at 3 to the x equals 27. So obviously these bases are not the same. However, we can rewrite 27. The question is, can we rewrite 27 as a base of 3? So we want to know what x is. So we're going to rewrite 27. And 27 can be rewritten because 3 times 3 is 9, and then 9 times 3 is 27. So 27 is the same as 3 to the third power. Well, now our bases are the same. Our bases are both 3, which means that our exponents are the same. So x is equal to 3. All right. Let's try this one. 5 to the x equals 125. So we want to get our bases the same. So the question is 125, can that be rewritten as a base of 5? 5 to some power. Well, yes, 5 to the third power is 125, which means that x is equal to 3. Let's look at this one. 2 to the x plus 3 equals 32. So the question is can 32 be rewritten as a base of 2 to some power? Well, 32 is the same as saying 2 to the 5th power, because 2 to the 5th power is 32. 2 times 2 times 2 times 2 times 2. So now we have 2 to the x plus 3 equals 2 to the 5th. And since the bases are the same, we both have 2 for the base, that means the exponents can be set equal to each other. So we get x plus 3 equals 5. And we can solve for x, and x will become 2. So your goal, no matter what, is to get the bases the same, because if the bases are the same, you can set the exponents equal to each other. Let's look at this one. 3 to the 2x equals 81. So again, we want 81 to be rewritten as a base of 3. So 3 to the 4th power is 81. So now we've got 2x equals 4. So divide by 2 and you get x equals 2. Let's try this one. 4 to the x equals 32. So here comes the problem. 32 cannot be rewritten as 4 to some power. That's an issue. So what base can both of these be written in? Well, 32 can't be written with a base of 4, but 32 can be written as a base of 2. And 4 can also be written as a base of 2. So now we're going to rewrite both bases, and both bases are going to now become 2. So when we do that, 4 can be rewritten as 2 to the 2nd power. And it's still going to have that exponent of x. It's just going to be on the outside. So 2 to the 2nd power to the x power. And then 32 can be written as 2 to the 5th power. So notice how our bases are now the same. Well, then we use our property 2 to the 2 to the 2nd power to the x power is 2 to the 2x power, because we just multiply our exponents here. So now we have 2 to the 2x equals 2 to the 5th. And so now we set our exponents equal to each other. So 2x equals 5, which means that x is equal to 5 over 2. All right, now let's do 9 to the x power equals 243. So 243 cannot be rewritten as 9 to some power. It cannot be rewritten as 9 as a base. However, 243 can be rewritten as 3 to a power, 3 to the 5th power. So since 243 can be rewritten as 3 to the 5th power, the question is, can 9 be rewritten as 3 to some power? Yes, 9 is 3 to the 2nd power. So now we'll rewrite both bases. So 9 will become 3 to the 2nd. It still has that x. And then 243 will become 3 to the 5th. So now we have 3 to the 2x, because we multiply our exponents, equals 3 to the 5th. So we set our exponents equal to each other. 2x equals 5, which means that x is equal to 5 halves. Let's look at this one. 8 to the x equals 128. So 128 cannot be rewritten as 8 to some power. However, 128 can be rewritten as 2 to the 7th power. So the question is, can 8 be rewritten as 2 to some power? Well, 8 can be rewritten as 2 to the 3rd power, which means that we're going to rewrite both of these bases. So 8 to the x power will be written as 2 to the 3rd to the x power equals, and then 128 will be rewritten as 2 to the 7th power. So we multiply our exponents. So 2 to the 3x equals 2 to the 7th. Set our exponents equal to each other. So 3x equals 7. And then solve for x. X is equal to 7 over 3. All right, let's look at this. 2 to the x power equals 1/2. This one is a little strange, but we have to remember, fractions just mean a negative exponent. So 1 over 2 is the same as saying 1 over 2 to the first power. And 1 over 2 to the first power, remember, if we move the denominator to the numerator, the exponent becomes negative. So 2 to the first power, we become 2 to the negative 1 power. So you might have learned it the opposite way. If we have 2 to the negative 1, remember, exponent doesn't want to be negative, so he moves to the denominator, and he becomes 2 to the first power, which is just 2, leaving 1 in your numerator. So we learned that property at the beginning of the year, and now we're going to use that property back and forth to get our bases to the same. Because if we write 1/2 as 2 to the negative 1 power, we now have bases that are the same. We have 2 to the x equals 2 to the negative 1. And so since our bases are the same, we can set our exponents equal to each other. So x is equal to negative 1. Let's try this one. 3 to the 2x plus 1 equals 1 over 27. Well, 27 is 3 to the third power. But if that's in the denominator, we don't want that 3 to the third power to be in the denominator. We want it to be in the numerator. So we'll make our exponent negative. So 3 to the negative 3. So now we got 3 to the 2x plus 1 equals 3 to the negative 3. We can set our exponents equal to each other. So 2x plus 1 equals negative 3. And then we solve for x. First we subtract 1. And then we divide by 2, giving us the answer x equals negative 2. All right, let's try this one. 5 to the 3x equals 1 over 125. So the question is can 125 be rewritten as 5 to some power? Well, yes, it can be rewritten as 5 to the third power. However, if we rewrite 125 as 5 to the third power, it's in the denominator. That doesn't help us. We want to move 5 to the third power to the numerator. So we have to make our exponent negative. So it'll become 5 to the negative third power. And so 3x equals negative 3. So divide each side by 3, and you get x equals negative 1. Let's look at this one. 9 to the 2x equals 1 over 27. So 27 cannot be rewritten as a base of 9. However, it can be rewritten as a base of 3. So this is a problem where both sides, the 9 and the 27, have to be rewritten as a base that they both share. And they both can be rewritten with a base of 3. So that's what we will do. The 9 will become 3 squared, because 9 is 3 squared. And we still have that 2 to the x power, okay, equals 27 is 3 to the third. However, we want it to be in the numerator. So we're going to make it 3 to the negative third. So now we've got 3 to the second times 3 to the second to the 2x equals 3 to the negative third. So 2 times 2x is 4x. So we get 3 to the 4x equals 3 to the negative 3. Our bases are the same, so we set our exponents equal to each other. So 4x equals negative 3, which means that x is equal to negative 3/4. All right, your turn. You're going to try 7.8, 2 through 6 evens.